Hello everyone. Today we are going to learn about matrices. What are matrices? Matrices are the plural of a matrix. Now what is a matrix? If we are given some numbers, say 1, 2, 3, 4, we want to arrange them in rows and columns. It can be done as this. Now we enclose this arrangement by brackets. In this case, the horizontal lines are called the rows and the vertical lines are called the columns. So in our arrangement, we have 2 rows and 2 columns. Now this arrangement of numbers in rows and columns enclosed by brackets is called a matrix. Now matrix is always denoted by any capital alphabet. Now the numbers which constitute the matrix are called the elements of the matrix. In the above examples, there are 4 numbers which form the matrix, so there are 4 elements. Now, what is order of a matrix? It is defined as number of rows into number of columns. In the above examples, there are 2 rows and 2 columns, so the order is 2 into 2. Let's take some more examples for order of a matrix. Now we take A as 1, 2, 3. Now the order over here will be 1 row and 3 columns. So the order is 1 by 3. Now let's take one more example. B is equal to 2, 3. In this case, there are 2 rows and 1 column. So the order of this will be 2 by 1. We let it be as 2 by 1 because it tells us that there are 2 rows and 1 column. Now we move on to types of matrices. Row matrix. It has only 1 row. Column matrix. It has only 1 column. Rectangular matrix. It has unequal number of rows and columns. Then we have square matrix. It has equal number of rows and columns. Next we have is zero matrix or null matrix. This has all elements as 0. This could be either a rectangular matrix or a square matrix. Next and the most important one is the identity matrix or the unit matrix. This is a square matrix in which the diagonal elements from top left to bottom right are 1 and remaining all elements are 0. This is always denoted by capital I. So a 2 by 2 identity matrix will be 1, 0, 0, 1. Similarly, a 3 by 3 identity matrix will be 1, 0, 0, 0, 1, 0, 0, 0, 1. Now if we take an example 0, 1, 1, 0, will this be an identity matrix? No, this will not be an identity matrix because it has to be diagonally from top left to bottom right. Now we learn about addition and subtraction of matrices. 2 matrices can be added or subtracted only if they have the same order. Let's take an example. We have 2 matrices A and B of the same order. To add 2 matrices, we simply add the corresponding elements. That is, the first element will be 1 plus 4, 5. Second element, 2 plus 3, 5. Third element, 3 plus 2, 5. And the fourth element will be 4 plus 1, 5. Now similarly, we can subtract 2 matrices as the first element 1 minus 4, we get minus 3. Second element 2 minus 3, minus 1. Third element 3 minus 2, 1. And the fourth element 4 minus 1, 3. Now let's start with the problems based on addition and subtraction of matrices. Let's take the first example. If we are given a matrix A and we are given the equation 2a plus 3x is equal to 0, we want to solve this. To solve this equation means to find x. Here A is a matrix, so obviously x is going to be a matrix. So in short, we are asked to find the matrix X. Let's make X the subject of the equation. We have 2a plus 3x is equal to 0. So 3x is equal to minus 2a. That is, x is equal to minus 2 by 3 times the matrix A. Now we have a number before the matrix. In this case, we have to multiply each and every element of the matrix with that number. So we get the answer as And here's the next problem. Now, if the first matrix minus 3x is equal to second matrix, we want to solve this, that is again to find the matrix X. Same way, we make X the subject of the equation. Now, in this case, we have minus 3x. So, let's take minus 3x to the right side and take the matrix on the right to the left. We subtract the two matrices. We get the result as this is equal to 3x. Now we find x as 1 upon 3 of the new matrix formed. That is, multiply each and every element of the matrix by 1 upon 3. And the answer obtained is Now let's move on to the next problem. Here we are given two matrices A and B. We are asked to find the matrix X such that 2x plus 3a minus 4b equal to 0. In this case, again, we will make X the subject of the equation. Let's transfer A and B's to the other side. We get 2x equals 4b minus 3a. Now substitute the matrix B and the matrix A. Now we have 4 times the matrix B. That is, multiply each and every element of B by 4. Then we have minus 3a. Here we have two options. We multiply each and every element of A by 3 and let minus sign be outside. Or we multiply each and every element of A by minus 3 and let plus sign be outside. Now, on adding these two matrices, that is simply adding their corresponding elements, we get the answer as Now we are going to learn about multiplication of matrices. Two matrices A and B can be multiplied only if the number of columns of A is equal to the number of rows of B. Let's take some examples. If A has order 2 by 3 and B has order 3 by 2. In this case, number of columns in A is 3 and number of rows in B is again 3. So we can multiply these two matrices. When we multiply, a new matrix will be formed. We can call it as product matrix, say C. It will have order as number of rows of A into number of columns of B. So we get the order as 2 by 2. One more example. A has order 1 by 2. B has order 2 by 2. Again, the number of columns of A is equal to the number of rows of B. So we can multiply and the order of C will be number of rows of A into number of columns of B, which is 1 by 2. Now let's see how we are actually going to multiply two matrices. Let's take A and B of order 2 by 2. Now we need to remember this. Whenever we multiply two matrices, the rows are to be taken for the first matrix and the columns of the second matrix. Now we have two matrices A and B. Now since the order of both these matrices is 2 by 2, the order of the product matrix will again be 2 by 2. It means it will have 4 elements. The first element will be obtained as first row into first column. We get 1 into 0 plus 2 into 3. For the second element, we take the first row multiplied by the second column. We get 1 into 2 plus 2 into 1. Third element, second row, first column. We get 3 into 0 plus 4 into 3. The fourth element, second row, multiplied by the second column. We get 3 into 2 plus 4 into 1. Now we simplify this. 1 into 0. Mind you, it is 0 and not 1. So we get 0 plus 6, 2 plus 2, 0 plus 12 and 6 plus 4. We again further simplify this as 6, 4, 12 and 10. So this is how we do multiplication of matrices. Now let's switch over to the properties on multiplication of matrices. What do you think? Will A into B be the same as B into A? We can try that out. Now, how can we multiply two matrices? If the number of columns of the first matrix is equal to the number of rows of the second matrix. So, you will get many cases where you can find A into B, but when you do B into A, that matrix multiplication is not possible at all. So, we cannot say that A into B is always equal to B into A. But again, there will be some cases where A into B will be equal to B into A. So, in general, they are not equal. Now, this property A into B equals B into A is called commutative property, but here in matrices, multiplication is not commutative. Now, second property, A into B into C is equal to A into B into C. Now, we take three matrices of order, say 2 by 2. We multiply A and B, then multiply that product with C. Now, take the right side. We first do A into the product of B into C. We have to get both the sides as equal. If we do not get, it means we are wrong in our calculation somewhere. This property is called associative property. Now, the third property, A into B plus C is equal to A into B plus A into C. This property is called distributive property. Now the fourth one, if A into B is equal to 0 given, can we say that either A is 0 or B is 0 or both are 0? Will this always be true? Or is it possible that A and B both are non-zero but still their product will be 0? Let's take an example. So we have seen A and B both are not 0 but their product is 0. So A into B equal to 0 does not imply that one of them has to be 0. Now the next property, if A is 0 or B is 0, does it mean that A into B is 0? Yes, this will always be true. That is, if one of them is 0, then their product will be 0. Now next one, B into I, where I is an identity matrix. Will it be the same as I into B? You can check this out. Take two matrices, B of order 2 by 2, I again of order 2 by 2. You remember what will I be? I will be 1, 0, 0, 1. So multiply B with I and then multiply I with B. We have to get the same answer as B. Now we will be solving some problems based on multiplication of matrices. Now we are given three matrices A, B, C of the same order. We are asked to find C into B minus A. So in this case, we will first find B minus A and then multiply C with that new matrix. Now let's see how to find B minus A. To find B minus A, we subtract the corresponding elements as 2 minus 1, 1, 1 minus 2, minus 1, 3 minus 2, 1 and 2 minus 3, minus 1. The order of C is 2 by 2 and B minus A is also 2 by 2. So we can multiply these two matrices and the order of the new matrix will be 2 by 2. Now the first element will be first row into first column, that is 1 into 1 plus 3 into 1. Second element, first row into second column, so we get 1 into minus 1 plus 3 into minus 1. Third element will be second row into first column. So we get 3 into 1 plus 1 into 1. And the fourth element will be second row into second column. We get 3 into minus 1 plus 1 into minus 1. Now we simplify this as 1 plus 3 minus 1 minus 3, 3 plus 1 minus 3 minus 1. Further simplify as 4 minus 4, 4 minus 4. So this is the answer. Now to the next problem. Here we are given three matrices A, B and C of order 2 by 2. We are asked to compute A into B plus C and B plus C into A. Now to solve this problem, we will first find B plus C. We add the corresponding elements. We get 2 plus 5, 7, 1 plus 1, 2, 4 plus 7, 11 and 2 plus 4, 6. Now we multiply A with B plus C. Now again the order of A is 2 by 2 and B plus C is 2 by 2. So we multiply as row 1 column 1, row 1 column 2, row 2 column 1 and row 2 column 2. We get 7 plus 22, then second element 2 plus 12, third element 21 plus 44 and the fourth element as 6 plus 24. So we simplify to get 29, 14, 65 and 30. That's the answer. Now we are also asked to find B plus C into A. What do you think? Will B plus C into A be the same as A into B plus C? Let's check it out. To find B plus C into A, we will multiply B plus C with A. Now B plus C we have already found out earlier. Now let's multiply. The first element will be row 1 into column 1, that gives us 7 plus 6. The second element will be row 1 into column 2, that gives 14 plus 8. Third element row 2 into column 1, which gives 11 plus 18. And the fourth element row 2 into column 2, which gives 22 plus 24. Now we simplify this as 13, 22, 29, 46. So here we observe that A into B plus C is not the same as B plus C into A. The simple reason for this is matrix multiplication is not commutative.